So lesson 1.3 is all about measuring segments, not like with a ruler, but the thing we start with is called the ruler postulate, which I'm not even going to write it out. We don't do a ton with it, but I want you to understand how you find a length to something, how you find a distance between points. So we are going to do a little bit of algebra. I don't remember if it was this class or a different class, but someone was like, why are we doing absolute value in the homework a couple days ago? Was that this class? Today is the reason we were doing absolute value, because you're going to do a little bit of absolute value with the geometry today. So what we're going to start with, it's called the ruler postulate. Like I said, I'm not going to write out a definition and all that. I'm just going to show you how this works because you will use it today. Okay, so we're going to say you have segment AB, and point A is at A units, and point B is at B units. Okay, so if you need numbers to kind of visualize it, pretend A is at -2 and B is at 7. Okay, they're just unknowns right now, but if you need to see a number, that's what I'm getting at here. Okay, one's at -2, one's at 7, for instance. The ruler postulate says if I want to know the length of AB, so how long is it from point A to point B, what I do is I take their values, so A and B, I subtract them, and I take their absolute value. What does absolute value do?
Makes it positive.
It makes it positive. Do you know why it makes it positive? It's not just this like magical like poof, positive. It's actually got a purpose, or it's got a reason that it's positive. Absolute value is the distance from 0. So if I'm at 0 and I go 3 units to the left, that's a -3, right? But the length of that segment is 3 units long. It's not -3 units long, right? It's 3 units long. So that's what absolute value does, is it just tells you how far from 0 are you, okay? So if I want to know how far it is from A to B, I subtract A minus B, or you could do B minus A. It doesn't matter the order you do it. You subtract them, and you take the absolute value, okay? So let me just show you an example of that. Let's say you have a number line, and S is at -4, and T is at 8. So there is a 0 in there somewhere, right? And I want to know what is the length of ST. Notice this for me real quick. I didn't put anything over that ST. Whenever they're talking length, like how long is it, it's just the letters. You don't put a bar over it, you don't put arrows over it, it's just the letters, okay? So if I want to know the length of ST, what I'm going to do is I'm going to take my S value, -4, my T value, 8, and I'm going to subtract them and take the absolute value. So ST would be -4 minus 8 is a -12, so the absolute value of -12, and what is the absolute value of -12? 12, okay? It's always going to make it positive because it's just a distance. It's how far from 0 is it. So it is 12 units long, okay? Questions on that? Okay. One thing to note, I just mentioned this up here. When you see ST with nothing over it, it's talking about a length. When you see ST with the bar over it, it's referring to the segment itself, right? So if I'm talking about a segment, they're going to put a bar over it. But if they're asking for the length of that segment, there won't be a bar, okay? Just to help you when you read a problem, it'll make more sense if you understand that. Okay. I'm going to give you a postulate right now that you're going to use a lot in geometry. It is called the segment addition postulate. And my guess is most of you right now could give me this postulate without me telling you what it is. If I just kind of explained to you the process, you could probably say, oh, so it should be, and you'd fill in the blank. We'll see if you can. Let's say I have point A, point B, and point C here. Okay? Segment addition postulate says the length of AB plus the length of BC equals what? AC, right? The two parts added together equal the whole thing, which maybe looks super simple right now. You'll see how when we throw the geometry in, there's just more involved. And that's what we're gonna do right now. So segment addition is take the two parts, add them together, you should get the whole thing. And here's what that will look like in the world of geometry. So this is example 2. And it says this: if EG is 59, okay, so the length of EG is 59, what are EF and FG? And then the beautiful thing about geometry, if you like pictures, you get lots of pictures in geometry. If you don't like pictures, I'm sorry. You're gonna get lots of pictures. So let's say this is E, this is F, this is G. And in the question, they will give you this. They'll say this is 8x, minus 14. And they'll say this is 4x plus 1. Okay, so this is what you're given. If EG is 59, what are the lengths of EF and the length of FG? What would you do? Do you see it? Add what?
8x minus 14 plus 4x plus 1.
Right, so we have to add 8x minus 14 to 4x plus 1. And what do we set that equal to? The 59, okay? And I would say, so if you think back to algebra, I feel like most of the directions in algebra class say solve or evaluate or simplify, right? It was very like, here's all the stuff you need, now simplify it. Geometry is a little different in that usually the directions for the problem tell you something you need in the problem, okay? So for instance, this in our instructions for the problem, you need that 59. Don't forget that it's there. That I feel like gets forgotten a lot. So this would be your setup. Now you can go back to algebra land if you like algebra better. So 8x plus 4x is 12x. Don't forget this is a negative 14 plus 1 would be a negative 13 equals 59. We're going to add 13 to both sides. And we get 12x equals 72. And then divide by 12. And x is 6. Are we done?
Nah.
Why not?
Because it's assuming that
You have to put the x.
It's a good assumption.
You have to put the x back in the two problems like the EF.
Right. So the question they asked is what are EF and FG? So don't stop at x, okay? We found x, now you got to plug it in. So you're going to say EF is 8x minus 14, so 8 times x, or 8 times 6, minus 14. So if you simplify that, what's 8 times 6? Mental math? 48. Good job. Did you guys like times tables back in the day? I love them. Do you know the 9 trick? Okay, anyway, 9s are fun. So if we're plugging this in, 8 times 6 you said was 48, right? 48 minus 14 is 34. Okay, so EF is 34. And then you're going to do the same thing. We need to find FG. So to find FG, That was the 4x plus 1. So 4 times 6 plus 1 is 24 plus 1. So FG is 25. How do you know you got it right? If you look at these two and add them together, they should equal the 59, and they do. Okay? Questions on that? Okay. Moving right along. Have you ever heard of congruence before? Good. We're going to be talking about congruent segments. Hey, I'm up here. The symbol for congruent is an equal sign with a tilde over top. So if you think a keyboard on a computer, it's that top left key, right? Is that little tilde. You put that over top of an equal sign. So congruent segments is what we're going to talk about right now. You can kind of see it in the symbol. Congruence is just saying that segments are equal in length. Okay, so let's say I give you this setup. Say this is a rectangle and it's A, B, C, and D. Basically what this is saying is if AB is equal in length to CD, then we can say that AB as a segment is congruent to CD as a segment. Okay, so if they are equal in length, they are congruent. They're pretty much interchangeable, congruence and equality. Okay. So with that, there's a way we mark it congruent, because maybe AB and CD are congruent, but then also BC and AD are congruent, okay? I can say BC and AD are the same length by putting a hash mark on each one of them. But now we have a second set of congruent segments, and we can't just do a single hash mark because that would say all 4 of them are equal in length. So now what you need to do is just do a double hash mark. Okay, so that's saying AB is congruent to CD and AD is congruent to BC. Okay, any questions on that? Okay, notice how it's written, right? AB with the segment over top is congruent to CD. When they're saying they are equal, you don't put the bar over top and you don't put the tilde on top of the equal sign. Okay? Okay, so if you need to determine if segments are congruent, we learned earlier how you figure out the length of a segment. What did we say? How do you find the length of a segment if you know the numbers? How? Absolute value of the difference, right? So if I said, is this segment congruent to this segment, I would take the absolute value of the difference here, the absolute value of the difference here, and just see, did I get the same number? Okay? We're not going to walk through that right now, but you're using that concept with congruence. Okay, I have 2 definitions for you that are really could technically be the same definition. It's just there's a different word that you need to make sure you understand. First thing is midpoint of a segment. Can anyone tell me what a midpoint is? The middle point, right? Midpoint, middle point. So a midpoint is a point that divides a segment into 2 equal parts. Or 2 equal segments, you could say. Parts is fine too. Okay, so it's a point that cuts the segment into 2 equal segments. That's a midpoint of a segment. The other term that we're going to define is a segment bisector, and it's very closely related. With this one, anyone know what bisector is? What a bisector is? That's they intersect, but what is it to bisect? Not in 2 places, but into 2 equal parts, right? Bi is 2. So a segment bisector is going to cut a segment into 2 equal parts. The only difference, it is a midpoint, would be a bisector, right? The only difference from that is this can be a point, line, ray, or segment that cuts a segment into 2 equal parts. Okay, so let me just draw you a picture of what both of those things would look like. Let's see here. So you have a segment. Okay, the midpoint of the segment would be the point that makes those 2 parts equal, right? So my midpoint would be this point right here. If I want a segment bisector, that point meets the definition of a segment bisector, right? But I can also have something like this, right? A line that goes through. So the segment bisector would be that line, or maybe it's a ray, or maybe it's another segment. So it's really doing the same thing. It's breaking it into 2 equal parts. Okay? Any questions on that? Okay. So here's the deal. This next example that I'm going to show you is a lot like the second example that I showed you, but you do it differently. They look a lot alike, you do it differently. So if I lost you, come back to me right now, because this is where people get confused on which one is which. So they look a lot alike. The definitions of our terms will help us a lot with this. So let's say this is example 3. And it's going to say Q is the midpoint. Of segment PR. What are PQ, QR, and PR? Okay, notice there's no bars over those. That means they're looking for the length of those segments. Okay, they're gonna give you this. P, Q, and R. And this is 6x minus 7 and 5x plus 1. Okay, so notice how much that looks like example 2, right? You have a segment, you have 2 expressions with the segments that are broken into 2 different segments. But this problem is different. What's the difference in this problem from that first one? Yeah.
They're like axes for like P, Q, and stuff like that. Like, and they gave us a midpoint.
They gave us a midpoint. Okay, so again, like I said, the instructions for the problem are huge. This one says Q is the midpoint. That means that PQ and QR are congruent, right? So how do I set this one up different from the last one? With an equal sign. You're just going to set these equal to each other, okay? Instead of adding them together like we did on the last one, you're going to set them equal. So it's going to be 6x minus 7 equals 5x plus 1, and you solve, okay? So if we solve this, take away the 5x, we end up with an x over here. If we add 7 over here, we end up with an 8 on this side. So you get x equals 8. Okay? The question asks for the lengths of the 3 different segments. So you're just plugging that 8 in. Now here's the thing. Do you have to plug it in 3 different times? You really don't. Once you plug it in once, you should know all of it. I would check it just to be sure, but you shouldn't have to plug it into everything to get your answer. So for instance, PQ is 6 times x, which is 8, minus 7. What was 6 times 8? 48 minus 1 is 41. Okay, so PQ is 41. So what is QR? should be 41. Now, I would still plug it in just to make sure. So QR is 5 times 8 plus 1. So 40 plus 1 is 41. So then you know you did it right, which means the last thing they asked you for, PR, what do? Just add those together, 82. You're gonna go 41 plus 41 is 82. Okay? So just be careful. 2 different types of problems that look identical if you're looking at just a picture of them, right? Pay attention to what the directions are asking you for. Is it a midpoint or a bisector? Or are they giving you the whole length of it and you need to add them together and set it equal to the total? Okay? Any questions on that?